Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 11 students and the topic of discussion is complex numbers. In this video, we will be focusing on the NCERT solutions for exercise number 1. In the first problem, we have to express the complex number 5i into minus 3 by 5i in the form a plus ib. What is a plus ib? A plus ib is the standard form of the complex number. So you may be asked in another way to express the complex number in the standard form. So let us try to convert this into a plus ib. 5i into minus 3 by 5i. We first multiply the real parts, 5 into minus 3 by 5 and I into I. 5 will get cancelled, so minus 3 I square. I square is minus 1. We know that this formula is very important. For all the problems in this exercise, we will see that this formula is frequently used. So I square is minus 1, minus 3 into minus 1 is 3. So 3 is the real part and 0 is the imaginary part. The second problem, we have to express the complex number I power 9 plus I power 19 in the form a plus ib. Whenever you are given a problem like this where I to the power some big number is there, like in this one, we convert the odd power into next lowest even integer. For example, here I to the power 9 is there. So I to the power 9 will be written as I into I power 8. 8 is the next lowest even integer to the odd value. Similarly, I to the power 19, the lowest next lowest even integer is 18. So we write is I into I power 18. If it was already some even power, we will leave it as it is. Only for odd powers only we will convert to next lowest even integer. So I power 9 is written as I into I power 8 and I power 19 is written as I into I power 18. Why we wanted to convert this to even form will be visible in the next step. Now I power 8 can be written as I square into power 4. Why we are writing I square? Because I square is minus 1. We know that. So all these things will be converted into I square form basically. That is why we are putting in even number. Similarly, I power 18 can be written as I square power 9. I will be kept as it is. So I square is minus 1 power 4. This will be minus 1 power 9. So this will be an even number. This will be minus 1. This will be 1 and this will be minus 1. Now I into 1 is I into minus 1 is minus I. So this will be 0. So there will be neither a real part nor an imaginary part. And we have to write in the form a plus ib. So we write it as 0 plus I0. In the next problem, we have to express the complex number I to the power 39 in the form a plus ib. So this is, I to the power minus 39. Again, this is an odd number. So the next lowest even integer will be 38. So we write this as I power minus 39 as 1 over I power 39. So this will be written in even integer. So I power 38 into I. So again I square power 19. I square is minus 1. So we substituted minus 1 power 19, which is minus 1. So this will be 1 over minus I. Now we have to remove I from the denominator. So multiplying both sides by minus I. You can also multiply both sides by I also. It will give the same result. So this will be plus I square and top will be minus I plus I square will be minus 1. So this will be minus 1 minus 1 will get cancelled. Only I will remain. The real part is 0. So the complex number in a plus ib form is 0 plus I. In this problem, we have to express the complex number in the form a plus ib. So first we open up the bracket and multiply each term, like 3 into 7, then 3 into I7, 3 into I7, then I into 7 and I into I7. That's what we have written here. Now 3 into 7 is 21, 3 into I7 is 21I. I into 7 is 7i. I into I7 is 7i square. That's what is given here. I square is minus 1. So this will be 21 minus 7 will be 14. And the balance will be 21i plus 7i, which is 28i. Now we have to express the complex number in the form a plus ib. So we just open the bracket. So it will be 1 minus I plus 1 minus 6i. That's what we have written here. Now we add up or compile together the real parts. So 1 plus 1 is 2, minus I minus 6i is minus 7i. So whenever this algebraic expression is given, addition, subtraction, we have to combine the real parts separately and the imaginary parts separately. That is the key. Express the complex number 1 by 5 plus I2 by 5 minus 4 plus I5 by 2 in the form a plus ib. So this is the expression. We first open up the bracket. So this will become minus 4 minus I5 by 2. Now we compile together the real parts. So this will be 1 by 5 minus 4 and the imaginary part I2 by 5 minus I5 by 2. So it is given like this. So this real part we take the LCM. This will be 5 into 4 20. 1 minus 20 will be minus 19 by 5. So this LCM will be 10 and we cross multiply. So 4 minus 25, which is minus 21 by 10. So this is the final answer. Express the complex number this in the form a plus ib. So there are three terms given now. So we open the bracket first here. So it will become minus 4 by 3 plus I. It will become plus 4 by 3 and minus I. Now there are three real parts, 1 by 3, 4 and plus 4 by 3. So they will be adding together. Real parts are to be added separately and imaginary parts are to be added separately. Now we compile the imaginary parts. I7 by 3, I1 by 3 minus I. So it will be minus 1. I is taken common. So simply we take LCM and get the final answer as 17 by 3 plus I5 by 3. Express the complex number 1 minus I the whole power 4 in the form a plus ib. So this can be written as 1 minus I square to the power square. It should be 1 minus I to the power 4. Now we separately solve this. What is a minus b the whole square? This is a square plus b square minus 2ab. So each one will be 1 plus I square minus 2i. 1 plus I square is minus 1. So minus 2i, this is repeated because they are the same expression. So 1 minus 1 will get cancelled. This will be minus 2i into minus 2i, which is 4i square. I square is minus 1. 4 into minus 1 minus 4. And now there will be no imaginary part. So we can write this in a plus ib form as minus 4 plus 0i. Express the complex number 1 by 3 plus 3i to the power whole cube in the form a plus ib. Now we know the formula a plus b the whole cube is a cube plus b cube plus 3ab into a plus b. That's what we'll take a as 1 by 3, b as 3i. That's what we have taken and put in this formula. So 1 by 3 cube plus 3i cube plus 3 into 1 by 3 into 3i into 1 by 3 plus 3i. We are just putting a and b in this formula. So this will be 1 over 27. This will be 3 cube into I cube. This will 3 will get cancelled. So 3i into 1 by 3 plus 3i. And we keep simplifying. Put I cube as I square into I. And I square as minus 1. So we get this as I square as minus 1 into I. So this will be minus 1. If we simplify, we get it as minus 242 by 27 minus I26. So it is in the form a plus ib. Again express the complex number minus 2 minus 1 by 3i the whole power cube in the form a plus ib. So this will be minus 1 can be taken out. When we take out, it will be minus 1 power 3, which is minus 1, and it will be balance will be 2 plus 1 by 3i the whole cube. Again we have to put in this form. So we can just using this formula where a will be 2 and b will be 1 by 3, we just substitute in this formula and solve it further. Wherever I cube was there, we will write it in the next lowest integer form, which is I square into I. So I cube will be written as I square into I, and I square we will put it as minus 1. Here I square we can directly substitute as minus 1. And if we solve it, we get the expression minus 22 by 3 minus 107 by 27 I. In this problem, we have to find the multiplicative inverse of 4 minus 3i. So what is multiplicative inverse? It is 1 over this expression. So if this is a complex number z, its multiplicative inverse will be 1 over z. So what will be the multiplicative inverse of 4 minus 3i? It will be 1 by 4 minus 3. This is the multiplicative inverse, but we need to put in the standard form. Now if you want to convert this into standard form, we have to rationalize it. What is rationalizing? Rationalizing means removing the I term from the denominator. So how do we do that? It is given in the form a minus b. So if we multiply both sides by a plus b, this will become a square minus b square, and I square term will get vanished. So we multiply now both by 4 plus 3i and by 4 plus 3i. Denominator will be 16 minus 9i square. Numerator will be 4 plus 3i. I square is minus 1. So 16 minus 9 into minus 1, it will be 16 plus 9, which is 25. So this will be 4 plus 3i by 25. Separating the numerator and this, 4 by 25 plus 3 by 25. Now again find the multiplicative inverse of root 5 plus 3i. We know that the multiplicative inverse of this will be 1 by square root 5 plus 3i. Now we have to rationalize. We have to remove the I term and the square root term from the denominator. So we multiply both numerator and denominator by root 5 minus 3i. This is root 5 minus 3. Both numerator and denominator are multiplying. So this is a plus b into a minus b, which is a square minus b square. So root 5 square minus 3i square. This will be 5 minus 9i square. I square is minus 1. So denominator will be 14. Denominator will be 14. Numerator will remain root 5 minus 3i. Separating the terms, root 5 by 14 minus 3 by 14i. In this problem, we have to find the multiplicative inverse of minus I. So we know the multiplicative inverse of z is 1 over z. So its multiplicative inverse is 1 over minus 1. So we have to rationalize. Rationalizing means you have to remove I from the denominator. So both numerator and denominator will be multiplied by the term I. So 1 by minus I into I by I. This will be I square denominator. So minus I square is plus 1. Numerator will be I. So I divided by plus 1 is I itself. Now express the following expression in the form a plus ib. This need to be put in the standard form. Let us observe this. In the numerator we have a plus b into a minus b form. Denominator is minus term is there, we can just separate it out. So top we will write in the a plus b into a minus b form, which is a square minus b square. So it will be 3 square minus I square root 5 square. So this will be like this. And denominator, when we separate the bracket, it will be root 3 plus root 2i minus root 3 plus I root 2. So root 3 term will get cancelled, and denominator will be 2 root 2i. Root 2i plus root 2i is 2 root 2i. And numerator will be 9 minus I square into 5. We have seen earlier I square is minus 1. So 9 plus 5 is 14. 14 by 2 root 2i. Let us simplify further. 14 by 2 root 2i into 2 root 2i by 2 root 2i. So as to remove I from the denominator. So it will be 2 square, which is 4 into root 2 into root 2 is 2 I square. Numerator will be 14 into 2, 28 root 2I. Now I square will be minus 1. I square is minus 1. So this will be, denominator will be minus 8. Numerator will be 28 root 2I. Further simplifying, we get this as minus 7 root 2 by 2I. Since we have to express the terms in a plus ib form, we add 0 here because only imaginary term is there. So we can write 0 plus minus 7 root 2 by 2I. So this puts the expression in standard form. Friends, with this we conclude the video. Hope you like this video. Please like and subscribe my channel. This will help me in releasing the videos quickly to you. Thank you very much, friends.